the centroid with regard to y-axis. The equation for x bar with regard to y-axis is sigma x times a divided to sigma a. That means that I need to divide this figure into several shapes, and I'm going to divide it this way. So this is going to be my figure 1. Then from here also this is going to be my figure 2, and this is going to be my figure 3. That means that this second rectangle has a length of 8 inch. I write it so that I don't make mistake. Now for each segment or each shape, I'm going to find x and a and plug it into this equation, and I will use the same shapes to calculate this iy. So segment 1, x is the distance from y. For this shape, it's going to be located somewhere in here, and the distance is half of 1 inch. That means that it's half inch. For shape 2, which is this second one, it's going to be somewhere in the middle, and that's going to be half of this 10 inch, and that's equal to 5 inch. Even though it's half of 8 inch, but because we have 1 inch in here, so it's going to be 4 plus 1, therefore it's 5. For figure 3 or shape 3, which is this one, it's going to be located somewhere in here, and you can see that it's 10 minus half, because this is 1 inch, so half of it is half here, and 10 minus half, that's going to be 9.5 inch. So the unit here is inch. Then the area for each segment, which is going to be inch square. So segment 1 is 3 times 1, that's going to be 3 inch square. Segment 2 is 8 times 1, and that's going to be 8 inch squared. That's why I wrote this 8, because if I don't write it, it's possible that I make mistake and take this 10 instead of 8. Now the third triangle or rectangle is again 8 times 1, and that's going to be 8 square inch again. So we need to write the sigma a. So it's going to be 8 plus 3, and that's going to be 19. Then I need to write this x dot a, and clearly that's going to be inch cube. So it's going to be half times 3, that's equal to 1.5. This one is going to be 5 times 8, that's going to be 40, and this one is 9.5 times 8, and if you do it, it's going to be 76. So 76, and the sigma, which we have in here, the denominator, is going to be 76 plus 40 plus 1.5, and if you do the math, it's going to be 117.5 inch cube. Now you can plug it into the equation, and it's going to give you x bar that you are looking for, and that's equal 117.9 divided to 19, and it's around 6.2 inch. So our centroid is somewhere in here. It's going to be 6.2 inch from y. That's part A of this problem. Let's go to part B. For part B, I'm going to use the same configuration. Therefore, I can use some of these parameters that I have. And equation for part B, you know that we are going to use the parallel axis. Ix is going to be Ix prime. So in order to find Ix prime, we use that table, and the equation that for each type of figure, we can use the equation to find the moment of inertia for that figure with regard to its centroid. So sorry, I have to write Iy it's asking for y. So iy is going to be iy prime plus a times dx square. So this dx is equal to x bar that we have in this particular example. So I'm going to transfer them in here. So this is half, this is 5, this is 9.5. Because dx is the distance between the centroid and y-axis, and I already calculated it. Therefore, I'm going to directly find this part first. So a dot dx square, because I have it here. I have a also, so I'm going to use a from here. So I have a, I transfer this one. I'm not going to transfer a, I'm just going to use it. So it's going to be a is 3 times 0.2 square, and that's going to be 70.75. For this one, it's going to be a, which is 8 times 5 square, and it's equal to 200. And for this one, it's 8 times 9.5 square, and that's equal to 722. So this part of the equation is solved. Now I need to find the second part. And you know that I am writing it here, ix prime or I y prime. As I said, there is table. It's tabulated for a rectangle with regard to y-axis, this y prime axis. It's going to be base times this h cube divided to 12. So base, which is parallel with the axis that we are looking for, and h cube divided to 3. Therefore, for this one, I'm writing in here ix prime. For the first figure, which is this figure in here, it's going to be equal, b is 3 times 1, the height is 1, cube divided to 12. And if you solve it, it's going to be 0.25 because it's 1 over 4. The second one is going to be 1 times, because the second one is this one. Your base is 1 and height is 8. So 1 times 8 cube divided to 12, and you solve it, you will get 42.7. And this third one, which is this rectangle here, it's going to be 8 times 1 cube divided to 12, and that's going to be around 0.7 if I round it up. Now I have both parameters for my ix or iy. I can solve it, and it's going to be sum of these two guys. So 0.75 plus 25 is going to be 1. 200 plus 42.7 is going to be 242.7, and 722.7 is the third one. And the total IY is the sum of these guys, and it's going to be 722.7 plus 242.7 and plus 1. If you solve it, you will get 966 inch cube. I forgot to write in here that these units are inch cube, inch over 4, my bad, inch over 4. So the result is 966, and we pretty much calculated for both